Let us do question number 1.2. The question is, the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. A. What is the distance between the two spheres? And B. What is the force on the second sphere due to the first? Let us solve this problem step by step. Given Q1, that is charge 1, is equal to 0.4 microcoulomb. That is equal to 0.4 into 10 to the power minus 6 coulomb. And Q2 is equal to minus 0.8 microcoulomb. And that is equal to minus 0.8 into 10 to the power minus 6 coulomb. Also, the force is given 0.2 Newton. And the missing quantity is R, the distance between these two charges. To find the distance, we can apply Coulomb's law. And according to Coulomb's law, force is equal to 1 upon 4 pi epsilon naught Q1 multiplied by Q2 upon R square. Or you can write it as F is equal to K, that is the proportionality constant, multiplied by Q1 Q2 upon R square. Also, we know the value of K, that is K is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Coming back to formula, that is F is equal to K Q1 Q2 upon R square. Here we have to find the value of R, so we will take R square on the left hand side, that is equal to K multiplied by Q1 Q2 upon F, and that implies R is equal to under root K Q1 Q2 upon F. Since the charges are unlike charges, the force will be attractive. Let us infuse the values now. So R is equal to under root, the value of K is 9 into 10 to the power 9, and then Q1 is 0.4 into 10 to the power minus 6, and Q2 is minus 0.8 into 10 to the power minus 6. So we will ignore the negative sign because we have already said that the force is attractive. So we will only use 0.8 into 10 to the power minus 6. And that is divided by 0.2. After this calculation, we get the value of R, that is equal to 0.12 meter. Let us focus on the second question, that is, what is the force on the second sphere due to the first? The forces will be the same because only two charges are acting here. So on the second charge, the force will be the same, 0.2 Newton, and the force is attractive. Why? Because the charges are unlike charges. The force on the second charge is equal to the force on the first charge but opposite in direction. This is possible because of the Newton's third law.